A very good afternoon, everyone, and welcome to our final segment of a 2-week-long Singapore Geospatial Week Plus 2020. We hope you had caught many of our webinars this week and last week and gained a lot of insights into what's happening in the geospatial industry. Without further ado, we have with us Herman Koemans, Principal Solutions Architect from AWS, who will be sharing more about AWS's GIS tools and open data. Can I welcome Herman Koemans to present his presentation? Herman, please.
Thanks very much for the introduction. And it's a privilege to be here. I thank you very much as well for hanging in until the very last session of the week. I'll be talking today about some of the capabilities of the AWS platform, and as well as giving some examples of customer stories and some history, I guess, about the history of maps and also kind of information silos and how to get over that. So I'd like to begin in sort of the relatively recent history and work my way back a little bit. This is a tweet that actually came out a couple of months ago from Jeff Barr. And Jeff, if you don't know him, actually runs the AWS blog and has done for many years. If you don't follow him, you absolutely should. But so he tweeted this little tidbit a couple of months ago, and it's a reflection of the kind of gradually maturing state of play of spatial capabilities on the AWS platform. Many of you may be familiar with Safe Software and FME. If you're not, they publish tools for doing a lot of geospatial workloads, and FME in particular is a sort of ingestion and processing tool. And you may also know that last year Redshift, which is Amazon's data warehouse product, also introduced spatial capabilities. That was the last in a line of products that has spatial capabilities. So going back a few years, we already have sort of Athena, which allows you to query data straight out of S3, which has spatial capabilities. Then there's things like Postgres with PostGIS and other things that you'd be familiar with. But so last year, Redshift, the data warehouse, added the ability to do spatial queries, and then this year FME have added direct driver support straight into the Redshift database. And I particularly just wanted to call out this little article on this blog because I didn't want to do like a super intense session now at the end of the week, but this is a great thing for you to go away and try on the weekend or next week. This is an exercise that you can literally do in 20 or 30 minutes. And if you just go to the Safe blog or Google Safe Redshift or FME Redshift, you'll find it really quickly. But it's a great little article. And in 20 minutes, what they do is they take some open data, 2 different open data sets, actually ingest it into the tool, put it back into Redshift, and then actually query it and do quite complicated matches, across the sort of 2 domains of spatial data. It's really quite remarkable what you can do in the space of 20 minutes and have a whole data warehouse stood up with a spatial capability. But so that's the kind of the state of play of the platform kind of right now. But I wanted to just take a little bit of a trip back. Initially go back a couple of years, look at some applications from the last couple of years, then go back a really long way, back to the 1400s, believe it or not. And I'm a map geek, so you'll have to bear with me while I map geek out for a second. But I'm going somewhere. And where I'm going is really about sharing data. But so first, I'd like to just sort of travel back, not quite so far in time, just a few years. So there's a great project called Blue Dot, which you can look up on the web yourself. And it's actually based on one of the AWS open data platforms. But the purpose of it is actually tracking water bodies. It's very important work. And so here on the screen, you'll see an example of like a water body and the outline traced, but then you can see the graph on the bottom of the screen where you can actually see the amount of water in that water body over time. And when you see that graph, you can very rapidly see a pattern forming there where every year there's a dip in the water level that's getting more severe every year. And obviously this is an example of really important kind of global work that needs to be done in terms of tracking water supply, climate change, population change, etc. The amazing thing about this, though, is that the kind of capability that Blue Dot developed costs them around €6 a month, which is just mind-boggling. So what they did is they've taken the Sentinel open data off AWS and just added some analysis. They didn't have to make a copy of the data. They didn't have to spin up any infrastructure. It's quite remarkable what you can do on a tiny budget, and something that in this case actually has global impact. And I'm going to talk a little bit more later about another example and work through how a customer did that, and also about some different ways of exposing data kind of in the end. But so first, to just go back a little bit further to sort of more traditional, I guess, GIS applications. So this is a topographic map from Switzerland. The Swiss actually have some of the most beautiful topographic maps in the world. They make lovely maps, but they also have some of the most beautiful topography in the world to begin with, of course. But so this goes back several years now. This actually is an example of an Esri stack running on AWS. And this map actually, straight off their website, it's actually the left half is the old paper map, and the right half is actually the Esri generated map, obviously in the style that deliberately mimics the old topographic maps. And if you have a look at their website now, they've moved along, over the years, and have amazing sort of 3D stuff built on top of similar style maps. But those kind of capabilities, lots of customers leverage on AWS as well. So moving something like a traditional Esri stack and moving it with a little bit of move and groove, some changes to make it more efficient and typically more performant and actually have it cost less money. But it's very traditional kind of stack move. And it's a stack that kind of creates a sort of a silo. And because that silo really often sort of just exists inside that one organization. And that's really what I'd like to talk about today. And so now I'm going to flip back much further than that. And if there are any fellow map geeks in the audience, you'll recognize this one straight away. And if not, you're in for a little treat, and just bear with me for a couple of minutes. So this is the Framora map. And so this is a map that was made around the year 1450. So more than 500 years ago. And this is one of the maps that actually represents the start of modern cartography. It's called Framora map because Framora was the monk in Venice who actually created the map over a period of several years. And it's a very early example of crowdsourcing. And when you look at it like this, it's very big. It's 2.5 meters across. So it's a very, very large map that still exists in Venice. To get an idea of why it's remarkable though, if I put this picture of the world next to it and you compare, you'll see it's actually quite a remarkably accurate map of the known world in 1450, although to our eyes it's upside down, which is why it's a little hard to recognize at first. But once you orient yourself the other way around with south at the top, you can very clearly identify the Mediterranean Sea and the boot of Italy. It's a remarkable feat, an incredible feat for the time. And actually, it was really one of the first times that sort of scientific methods started being applied. Previous to that, maps actually typically had a very kind of religious-centric view of the world. And so they'd often have the Garden of Eden in the middle, and they'd have whichever empire was producing the map near the middle, and then things would be larger depending on their importance rather than on their location. And so you'll see in the corner of the map here, the Garden of Eden's been moved off the map. So the religion is still acknowledged, but it's moved outside. And then the map itself was the most sort of accurate rendition they could manage of the real world. And so it still exists. It stands as this incredible sort of feat of map making by some people who were literally locked in a monastery in Venice, who'd never seen the rest of the world. And given the accuracy and the amount of information, and as you zoom in, you can start to see this like 3,000 inscriptions, and there's all different boat types and, incredibly useful information. But there's a huge problem with the map, which is that it's a very early version of a silo, because the map's enormous. It's 2.5 meters across. Of course, you can't move it. And so the sailors and merchants of the time could go and look at the map, but they couldn't actually take it with them. And so that problem actually wasn't solved till 100 years later. And about the same time as the map was developed, actually Gutenberg invented the printing press, but that was only good for letters. And about 100 years after that, then copperplate engraving was invented. And so that actually enabled people to engrave a map onto a piece of copper and then reproduce it onto a piece of paper. And so distribution of geospatial information was invented. And what that means is that finally that information could be unlocked, but it was done in a way of reproducing something. And that model of reproducing things instead of giving access to them is something that has stuck with us till this day, and to our detriment. But at the time, it was the best they could do to break down the silo so that you could actually roll up the map, take it with you, and jump on a boat or jump on your horse and actually explore and have a map with you. Now, we can do much better than that nowadays. We could do much better than making a copy of something. And if you're a little bit old, like I am, you'll remember the digital revolution from the sort of 80s and 90s, and people got super excited about the fact that you could make an exact copy of something. Finally, you didn't have an analog copy, which was always imperfect. You could make a perfect copy because it was digital. But we still do that today when we really don't need to. And as an example of the kinds of things that can be done, we established Earth on AWS. If you've never seen it, absolutely have a look at this URL afterwards. But so it's got everything from climate models to satellite imagery, elevation models, radar, lots of other data sets. Lots of those data sets are actually free to use. Some of them actually have request to pays buckets, which basically means somebody else can use it from the AWS account, but they just pay for the data transfer across. There's lots of different models for doing this. You can also commercialize data like this. But just by making this data available, we hoped that people would actually start innovating on that data. And that has absolutely happened over the last few years. Whole businesses have spun up off the fact that we just provide regularly updated global satellite imagery. It's just sitting there for anybody to use. And for example, there are whole companies that have sprung up actually doing weather forecasting based off the open data, which they then sell to markets to try and do improved high-speed weather forecasting to improve people's buying decisions, for example. And so there's whole classes of business that have spun up off this open data. Now I'm going to jump into a customer example, which kind of starts with that open data, but doesn't end with it. So this example is actually from one of our departments of environment here in Australia. I'm based in Melbourne, and this was a project that they undertook because they wanted to do a similar study about bodies of water to the one that we saw earlier, where we saw over 3 years, the extent of the bodies of water getting bigger and smaller, and obviously the amount of water changing. But they wanted to do a long-term study. And so they wanted to do a study over a period of 25 years. Now, the AWS open data would have been an okay starting place, but say the Sentinel satellite data, we've only got it sitting there for the last 3 or 4 years. And so that wasn't quite enough. But they knew that this data already existed and had been collected. And, if it weren't for that, the project, of course, would be enormous, because step one is collect 25 years of data. A, it's a 25-year project. B, how do you even do that? And then on top of that, 25 years of global satellite data is a lot of data, of course, so you have to work out how to store all of that data. Until recently, you would have been building, big SAN arrays on-prem or something like that to store all of that data. Then build a compute cluster to actually analyze all of that data, and then actually finally get the data scientists or the geospatial folk or whoever you've got to actually do the analytics on the data that you've got. And so it would normally be a daunting task to be able to do something like that. Now, in this particular case, come to the rescue Geosciences Australia. And so this is a terrific federal government agency here in Australia who aggregate spatial data across the different states in Australia and actually provide a lot of national scale data back out again. And most of that data they provide for free. And so included in that, in Digital Earth Australia, they actually have aggregated 30 years worth of satellite data of the country. And so anybody, any agency, anyone in Australia can actually go and look at that data. They've got it arranged into a data cube, you know, which if you're not familiar is essentially where you have kind of a 2D landscape and then a third dimension in time. And so you can kind of take slices spatially or temporally. But in the end, it's the 30 years of data sitting there on AWS. We're just waiting for anybody to use. And so that's an incredible example of a silo that's been broken. You know, it's not like every agency in Australia has to go and actually have their own version of that data. They don't need to make a copy of it. They don't need to drag it around. And the fact that it's available, you know, creates this amazing possibilities and this culture of innovation. And so, you know, for a Department of Environment, it's just vastly simpler because in the end, all you have to do is point some analytics at the data. And it doesn't matter if, it doesn't matter if you're using your favorite desktop tool. It doesn't matter if you're using sort of custom AI. You can use any of those kind of tools against the data. And in that particular case, they actually did something like this. And so you've got a geospatial data lake. And so you see that across the top. Where Amazon S3, so our storage platform, is the kind of bedrock of any kind of data lake. There's lots of ways that you can add to that though. Athena is kind of a no-brainer, which lets you query the data straight out of the storage platform, and you can query that spatially nowadays. And there's lots of other techniques that you can use for data lakes, including Elasticsearch, so I've mentioned there. You might temporarily ingest things into Redshift, you might do lots of other stuff. But that bedrock of the data lake stays there. And it's tempting to say, well, okay, I'm a government agency and I want to use the satellite data. I'll make a copy of it. I'll download it, but you don't need to. And so what they did was just access the data from AWS to AWS. They use SageMaker, which actually is one of our platforms for making machine learning much more accessible and simple. And so you basically have some models and some notebooks to essentially do the identification of the water bodies. And so obviously you need to work out, you look at the satellite picture, work out, you know, based on sort of reflectivity and color, you know, where is the water body, and then over time, is it getting bigger or smaller? The end output of that is a bunch of polygons. You know, so the end output of that is a bunch of dots and lines that describe the body of water. And so obviously they had to put that somewhere, and they put it in a Postgres database. And so if you go to Amazon RDS Postgres that supports the PostGIS extensions, you can just store all those points and lines in the database, and then you can still query them. And then they merrily use those in their favorite desktop application. And you know, in this particular case, they use a combination of QGIS, and they also use Esri desktop tools. But you can use any of those sort of regular desktop tools on AWS. And also they got ingested into other systems and servers. And so you think, terrific, that's a great solution. It is a great solution. Incredibly, you know, you're talking about the whole thing, doing like the analysis for 25 years worth of water bodies. It costs a few $100s. And it costs a few $100s because they were using sophisticated, you know, machine learning kind of techniques. It's incredibly efficient compared to having to provision all of that sort of infrastructure yourself. And also, you know, being able to, you know, go back, do it again next year, you know, all off the Geoscience Australia data. Now, there is a different thing that you would do if you did this today, though, because once you've got those polygons, you know, sure, you can put it in a Postgres database, but A, you're paying for the Postgres database as well. It's sitting there spinning away. But also, of course, once you've extracted that value, like once you've looked at all of that photographic imagery, established what the boundaries are, and now you've worked it out, why not share that with other organizations? You know, why create another silo? Because, you know, what they've done is, as is so tempting to do, they've created the value, but only look at it themselves. And in this case, it's a public government agency. Why not share that data back out again? You know, why not point the data back out at the data lake and then allow other agencies to leverage that data, or allow commercial organizations to leverage that data? It's extremely powerful. And I added Redshift along the top there as well, because, you know, the other thing you could do is temporarily put it into Redshift and then run very sophisticated, you know, data warehousing queries that include the spatial component, you know, because you might be interested in the relationship between forestry and the water, you know, or between other things and the water bodies. But so it brings up this question that I actually get asked an awful lot, because people think about, you know, all of this kind of satellite data and other product data that they've got, you know, that they've built and spent a lot of time on. You know, they think about, you know, the huge data sets they've got, and they say, well, no, I can't use cloud because I use QGIS, I use Esri Desktop, right? I can't copy all that data down. And so the super common question, how do I copy all that data down from the cloud? And the answer is really simple. The answer is don't. The answer is do not do it. The answer is you have to flip your mental model. You know, the really big satellite providers like Maxar, you know, they've just shifted all of this stuff onto AWS. And the idea is you leave it there. The idea is don't copy it down. There are some situations where maybe you need to copy it into your AWS account, mostly not. You know, but don't copy it down. So how does that work? I don't get it, right? This is a really common conversation. But so if you've got that data sitting there in S3, and so it can just lie there reliably, inexpensively in S3, no servers running, 11 nines of durability, just leave it there as long as you want, roll old data down to the glacier, and it becomes incredibly inexpensive. And so now what happens when you want to actually use that data? And so you'll see across the bottom of this slide, like customer 1, 2, 3 in the little boxes. Notice they're different customers. You know, notice I'm not talking about one customer here. And so you've got this body of data. It can actually be read by different customers. And as an organization, you can choose. You can actually choose to let people do that for free, or you can choose to monetize that. But either way, it doesn't have to be moved. It can just stay there. And so then what about my users sitting over there on the left? I've got my users and they want to use QGIS, right? I've got my users, they want to use Esri Desktop, or they want to use FME, they want to use whatever their favorite tool is. What you do is you project yourself into the cloud. So Amazon Workspaces, for example, can run a standard Windows or Linux desktop. And so what you do is you actually run your Windows desktop in the AWS region. Think of it like a thin client situation, if you want to think of it like that. Or think of it as a sort of remote desktop situation, depending on what you're used to. But you can just pay for that desktop by the minute and just run it in the cloud. This is an extremely common setup, say, for customers who run Esri. You know, the Esri desktop client, you know, is a very sort of mature and complicated client, which does lots of interactions with its server. It's very chatty, as we say. And so the way that our customers implement that is they move the Esri stack onto AWS, and then they just run their Esri desktop on AWS, on the actual workspace in the cloud. When Esri themselves rolled out, you know, the new flagship Desktop Pro product a couple of years ago, they actually used Amazon workspaces to deploy that around the world to train people, because you can just spin up GPU-enabled workspaces, run Windows in the cloud, and just pushing the desktop pixels down to a thin client that's on your computer works really well. You know, for example, we have customers in New Zealand that run Esri in Sydney across the Tasman Sea, and it works really well. And they do it like this. They run the Esri desktop in Sydney, and they run the Esri server in Sydney close together. And that actually means that it runs faster than it used to run on-prem. But if you're ingesting it some other way, same story. If you're writing some clever Lambda functions because you want to do reprojection, or you want to do you know, transformation operations, you run those Lambda functions right there against the original data, and then maybe you reproject, and then, you know, have your new projection out in a different bucket that either your organization owns, or you might be sharing back out again. If you want to do some clever stuff with machine learning, or just some regular servers, it doesn't matter. And so you can run any one of these regular either Windows or Linux-based applications against that data. It's super powerful. And so that's really the main thought that I'd like to leave you with at the end of these 2 weeks, which is for all of the products that you produce, you know, there's all this amazing work that gets done inside organizations. And it gets done inside both commercial and public sector organizations, and gets done for different reasons. You know, sometimes it's data that belongs in the public domain. Sometimes it's data that your organization is producing and maybe could get some value out of by selling it to other people. But if you just leave that data on S3 and give the appropriate access, whether it's open data or commercial or shared, it means you get rid of that awful silo mentality. You know, we've come a long way since having to actually do copper plate engraving and stamp something and make a copy of it. But so often people are still using IT as if it was that era. You know, let's make another copy of the data. And so, you know, my big message to you is we need to stop copying data, start using the incredible data that's available to us globally. I very much encourage you to have a look at Earth on AWS if you haven't already, just for some examples of how you can do that. And so thank you again for allowing me to close up this week. I hope you found the presentation useful, and I'm happy to take any questions that you might have.
Thank you, Herman. Thank you, Herman, for that presentation. So we might have some questions. Okay, well, we have one question here. Can we use open source software such as QGIS, Snap on top of AWS?
Yep, absolutely. And so there's a lot of the open source communities actually use AWS as the kind of sample sort of reference implementation for building things as well. And I do a lot of presenting at, you know, places like sort of FOSS4G and other open source conferences. So QGIS, for example, absolutely. So the simplest way to do that is actually, as I was just saying, you just spin up an Amazon workspace and you can just install QGIS on there. And then you can actually plug QGIS straight into like a Postgres RDS database. And so you can have a whole sort of database, desktop, keep it for an hour and then throw it away again. It works really well.
Okay. We have another question. Can we source for footfall data on AWS?
Interesting. I don't know if there's an open data set for that yet, but I'd be off Googling just like you were. But a lot of cities actually do have a lot of their public data as open data sets already. So, you know, whether it's pedestrian data or traffic data, taxi data, public transport. But so I'd have to go and look at it. I can't answer that off the top of my head. But frequently that's then, you know, the kind of data that will be provided by whoever is collecting that data in the first place. So they will provide it as an open data set rather than us.
Okay, another question. What is AWS doing to help with data discovery so customers can more easily identify useful data sources to blend together?
Yeah, I love that question. That's a terrific question. That's something that actually has been preoccupying us a little bit lately. And you know, it's actually an area where I've been looking for customer feedback. You know, because obviously, you know, you end up with lots of layers of things that would be interesting to combine. Anyway, but so we don't have anything that makes that easier for you right now. But it's an area where I've definitely been asking customers about, because you know, you can imagine it'd be interesting to have suggestions for taking everything from base map to city data to public transport data to, you know, to have some kind of central catalog of that, which doesn't exist right now.
Okay, so perhaps one more last question from the audience. Is there any support available for GIS tools on AWS Glue?
Yeah, so there's not specific support in Glue right now, and I actually think I think we'll see sort of more spatial support sort of roll out through different things in coming years. But so right now, the sort of the specifically spatial functions, like the sort of search polygon kind of functions that you find, are really in Athena, in Redshift, in RDS Postgres, and also in QuickSight, which is our business intelligence tool.
Okay, fantastic. So Herman, thank you so much for sharing with us more about AWS's GIS tools, GIS platform. I think for the audience, if you have any questions, any further questions, or you want to find out more about AWS's geospatial tools that are available, do check out their website. I believe you had shared it before during your presentation.
Yep, and otherwise just go to aws.amazon.com.
Okay, fantastic. So with that, thank you very much, Herman. Thank you for joining us in the Singapore Geospatial Week Plus series of webinars. And we hope to catch up again. We hope to see you again in future events.
My pleasure. Thanks very much.
Thank you, Herman.